Okay, this is a summary of some of the videos that we have done before about proportionality in physical science. Um, we have discussed that proportional and direct proportional are the same things. Inverse and indirect proportion are also the same thing. Sometimes you will see variation, direct variation and indirect variation. Uh, there are two conditions that must be met for there to be direct proportionality. That is, you must have a straight line, positive, with a positive gradient or positive slope, and that straight line must pass through the origin, which is 0, 0, x and y being 0 and 0 in their coordinates. In an inverse proportionality, there must be a curve. Is going to produce a curve with a negative slope. Also, if you multiply two sets of the points on x and y, you are going to produce a constant, which means that you're going to produce the same number. If you do not get the same number when you multiply those 2 points, if you don't, when you multiply corresponding points, if you don't get the same number, then you do not have an inverse proportionality condition. Also, y, if you say that y is inversely proportional to x, is the same thing as saying that y is directly proportional to either 1 over x, 1 over x squared, or 1 over x cubed. This is a situation in which, especially in physics, in which you want to take something that seems to be unproportional or indirectly proportional and make it proportional, meaning that you're trying to get it to have a positive slope, to have a straight line, and to have that straight line pass through the origin, which is 0 and 0, x 0 and y 0. In this video, I'll be looking at some various types of some various parts of a typical graph. So we'll be looking at several graphs, and this is going to be necessary to lay some foundations for subsequent videos on the same topic. So here we have the first one, and I will just mention a few things. Of course, this is the x value and the y value. Note that this is generally, well, it's supposed to be the independent variable that goes here. Independent variable is a thing that we are changing, whereas over here we have the dependent variable. In these examples, the dependent variables are generally the distance, or the velocity, or the acceleration, and the independent variable, which is what is constantly changing in terms of motion, is the time. Okay. This is the k is given as a slope. K is the slope of the line, and it can be found by the equation. Well, first of all, this is the equation of the line. Y is equal to kx, or x is equal to ky, and therefore you can use algebra. You can use some algebra to convert the k. K is equal to k is equal to y over x, or k is equal to x over y. In this case, we have a proportionality. So therefore, as x increases, y increases at the same rate. For example, that rate could be w. And as x decreases, the y decreases at the same rate. For example, the rate could be called s. But notice that the rate of s and the rate of w are not the same. I discussed that in a previous video. And of course, down here we have the straight line that passes through 0, and it's a condition of direct proportionality. Let's move on to the next slide. Alright, so in this one, basically the same thing, but I've omitted a number of things to show that this is the positive slope. This is a positive slope, If it were written like this, then this would have been a negative slope. Okay, this would have been a negative slope. In other words, if we had this, that would have been negative. Of course, that is not a condition of inverse proportionality, because in inverse proportionality, remember that it would have been a curve going in the same negative direction, but it would have been a curve. Don't forget that the constant k can also be written as an m. I think most times in math equation, you will see it written as an m, and it's also called a gradient. It's also called slope is also referred to as a gradient. So here we have a distance, which is location. Distance, location measured in meters, versus time is measured in seconds or hours or whatever. So this is a distance versus time graph. Okay, where k would be the slope, and the slope will be the velocity. So if you calculate what the slope is, it will give you the velocity. Okay, so we have now the velocity in meters per second versus time, velocity versus time, and in the velocity time graph, the slope would be the acceleration. Okay, that would be the acceleration. The velocity is meters over second. The velocity. So it would be meters over second over second. So that's why you'll get the acceleration. All right, and then we could have an acceleration versus time graph, and in an acceleration versus time graph, we have meters per second over second, which gives us meters per second squared. All right, and the slope of that line does not have a lot of meaning in certain circles, but it is in other circles is referred to as the jerk. All right. Here we have a situation where we have an inverse proportionality. Okay, notice that the graph is going in a negative. Well, the slope is a curve, and it has a negative shape. Right? It's negative, and that's what is considered an inverse proportionality. Inverse proportionality, and this is what it would look like with the same data. This is what I was talking about before, where sometimes, especially in physics, you take data that is inversely proportional and you manipulate the formula to use the same data to create a proportionality. And there's where you can get y is equal to 1 over x squared, or y is equal to 1 over x cubed. And when you do that, you could take a curve improportional or inversely proportional graph that is going negative, that is coming in this direction, in a negative direction, and you can turn it around and make it become a proportional, which means that it starts from 0 and it's a straight line coming out of the origin. Okay, so in our next video, I'm going to be talking about constants, constants k or m. Again, k is usually used when in physics or science, whereas m is typically used when we're doing math, but they're used interchangeably. Okay. Okay. Until next time, this is Nick. Thank you.